Howdy. That's a follow-up to the previous video. So, let's start somewhere. Telluric current. Telluric current is also called earth current, natural electric current flowing on and beneath the surface of the earth and generally following a direction parallel to the earth's surface. Telluric currents arise from charges moving to attain equilibrium between regions of differing electric potentials. These differences in potential are set up by several conditions, including very low frequency electromagnetic waves from space, particularly from the magnetosphere incident upon the Earth's surface, and moving charged masses into the ionosphere and the atmosphere, where we are. Telluric currents are often used by geophysicists to map subsurface structures such as sedimentary basins, layered rocks, and faults. An anomalous current density or gradient may be indicative of a subsurface structural feature. In some recent videos I have been mentioning the GIC, magnetically induced current. Yeah, it was about nuclear power plants. Geomagnetically induced currents, GIC, are electrical currents induced at the Earth's surface by rapid changes in the geomagnetic field caused by space weather events. GICs can affect the normal operation of long electrical conductor systems such as electric transmission grids and buried pipelines. The geomagnetic disturbances which induce GICs include geomagnetic storms and substorms, where the most severe disturbances occur at high geomagnetic latitudes. Background: the Earth's magnetic field varies over a wide range of timescales. Yes, the longer-term variations typically occurring over decades to millennia, 12,000 years for example, are predominantly the result of dynamo action in the Earth's core. Maybe not. Cowling dynamo. Geomagnetic variations and timescales of seconds to years also occur due to dynamic processes in the ionosphere, magnetosphere, and heliosphere. These changes are ultimately tied to variations associated with the solar activity or sunspot cycle and are manifestations of space weather. The fact that geomagnetic field does respond to solar conditions can be useful. For example, in investigating the Earth's structure using magnetotellurics, but also creates hazard. The geomagnetic hazard is primarily a risk to technology under the Earth's protective atmospheric blanket. For example, the Carrington event. But I just had to show you this because it's interesting. A time-varying magnetic field external to the Earth induces telluric currents, electric currents in the conducting ground. Yeah, some of these, they might be just a part of Earth's electrical circuit. And they are not induced by the sun because they are there already. They just get amplified or altered by the sun. These currents create a secondary internal magnetic field as a consequence of Faraday's law of induction. An electric field at the surface of the Earth is induced, associated with time variations of the magnetic field. The surface electric field causes electrical currents, known as geomagnetically induced currents, to flow in any conducting structure, for example, a power or a pipeline grid grounded in the Earth. The electric field, measured in volts per kilometer, acts as a voltage source across networks. And here's a picture. Induction. And we have also a small scale here. GIC in pipeline at Mansella in July 15th. Because the basic principle for the generation of GIC variations of the ionosphere currents generate an electric field driving GIC. Shown are also real GIC recordings from the Finnish natural gas pipeline. Finland once again, plate tectonic issues, the influence of electricity in rock forming process and the coherent connection between science, mythology and history of Finland. I wrote this some 2 years ago. If you scroll down, we will see the surface conductivity anomaly. There's geothermal activity, lightning bolts, craters, more craters, molten rock on top of metal, molten metal on top of rock. The surface conductivity anomaly, copper mines. Very interesting. And also, if you go even more down, we have Venus, the serpent of creation, Finnish history and mythology. There are also tales in Finnish culture which tell about dragons, so we maybe wouldn't have needed to go to Middle Europe or to the far north in order to find a dragon which relates to Finnish history, culture and mythology. His name is Iku Turso. The character is part of the Karelian and Finnish national epic Kalevala. And the Kalevala was, for those who don't know, a very great inspiration for those, or for the one who made Lord of the Rings. Yeah, there's a dragon there too. So now, from the ocean rose a giant, mighty Torsas, tall and hardy, pressed compactly all the grasses that the maidens had been raking. When the fire within them kindles, and the flames shoot up to heaven, till the windows burn to ashes, only ashes now remaining, of the graces raked together. Let me just emphasize this. And the flames shoot up to heaven. It might sound really, really crazy to many people. But as I have shown in my early video, that's a rock I found some time ago. And since it was yellow and looked rather interesting, I picked it up and brought it home. And this is just a small part of the video. I wanted to show you how it looks. Or better, how it looked. Because I was putting it into the microwave. Let's go to video player. And after it has been in the microwave for some time, you can see it in my previous video, it grew some blisters on top of it. Here something, and here. And it turned also red. Because it was yellow. Because it might contain sulfur. So, I was putting it again into the microwave. Obviously you can see it's now cooled down. That's the back side of it, so it has cracked in many places. Because it's growing. You know, there's stuff coming out of that stone. And I was putting it into the microwave. And basically the only thing I was surprised about this was that how quick the reaction started. And check it out. What happened? Put your volume up. Because you have to understand, the dragons, they are very loud. Maybe there's some gold or something. Doing some alchemy at home. Yeah, this started very quickly after I put it into the microwave. Remember? And the flames shoot up to heaven. Yeah, you can immediately hear when the microwaves are on or not. There's nothing going on if there is no microwave going on. And if you have a microwave at home and you hear the lower sound, then the microwaves are on. And if it just keeps or makes this normal sound, that there is no microwaves. So they are just on every now and then. And if you put in or increase the energy, what you are like, how quick you want to have something to get heated up, they are just more, like the time is more on. They're not strong or anything. They're just, the interval is just shorter of the breaks between the pulses of the microwaves. And remember, this is electromagnetic energy. This is just a basic microwave, some, I don't know, 15 years old or something. And just an average rock I found somewhere. Yeah, maybe not, but anyway. But we have to assume that these kinds of rocks are abundant. They're like billions of tons in the ground. And maybe many of those haven't ever been found. There's like still new minerals found and all kinds of things. So, and what do you think? If you compare this basic microwave oven and its ability to produce a certain amount of microwaves, and it's restricted. It's just a basic machine everybody has at home. Yeah, I know, not everybody, but many people have at home a microwave. And what do you think compared to the, let's say, universe? How much energy the universe could provide, which could transform into geomagnetically induced currents? So the tales from the ancients about flames shooting up from the ground could be proven correct just by this very simple experiment. Let's watch it again. And try to listen if you hear the lower sound of the microwave, when the microwave gets on actually. And then the higher sound, when there's nothing going on, it's just like it should spin there in the middle, but the glass is broken, everything is shredded, so it doesn't do anything. But anyway. Now there's this basic sound, there's no microwave, nothing's going on. No, you couldn't hear me, probably I was talking. Now there's microwaves again. And there is sparks flying. And we have flames shooting up. Yeah, what a smooth transition to Forbes. Flames shoot from a hole in the ground for 40 minutes. Weeks later, we still don't know why. This article is more than 4 years old. There's just a random picture. No photos were taken of the unexplained pillar of. Fire flared from a hole in the ground near Mountain Home, Arkansas. Shooting up to 12 feet in the air between 30 and 45 minutes before finally going out. That was 2 weeks ago, and since the bizarre, unexplained incident on private property, methane, meteors, and Satan have all been ruled out as possible causes by authorities. But definitive answers remain elusive. On September 17th, local volunteer fire chief Donald Tucker, what a combination of names, arrived on the scene where the odd inferno had been reported and watched until it went out. Tucker said he was too preoccupied trying to keep people away from the flames to think about taking any photos or videos of the strange scene. When he took a closer look at the scorched hole later, he said it looked to be over 3 feet deep, making a 45-degree turn at the bottom. I took a temperature reading of it and it showed 780 degrees inside the hole. Tucker told the Springfield, Missouri news leader at the time. But what caused it? I have no idea. There was no gas lines nearby and there was no smell of natural gas. There's actually a video.
The flames that shot up out of a hole in northern Arkansas remains a mystery at this point to experts and even county leaders. Caitlin Sinnett has more on what they are ruling out as the cause. An unusual call for the Midway Volunteer Fire Department. A volleyball-sized hole with flames shooting out of it off Highway 5 South in Midway.
The fire was burning roughly 2 feet in diameter, about 8 feet tall, and it burned for approximately 40 minutes.
The homeowner who lives nearby told us off camera he came outside Monday morning to flames shooting from the hole up to the man's nose on this billboard. Now county leaders are trying to figure out how the phenomenon started.
We don't believe that the devil showed up or the meteorites landed or the big booms happened.
So what did cause this hole and those flames? That's the burning question.
We have contacted every utility company that's in the area, and we know for a fact now that they have lost no service. They have nothing there, so it's nothing to do with the utilities, which would have been our first inclination to believe it was something there.
No one knows where the hole ends. A few geologists say they don't believe it was caused by a meteorite or lightning strike. And one with the Arkansas Geological Survey says how it started is a mystery.
I can't think of any geologic situation that allow that to happen. Not in this area. There's not any fossil fuels, coal, or natural gas or petroleum that occurs in the area.
But he wants to dig for some possible answers.
I imagine you would have to do some serious excavation to find out the source of that. We would be happy to go up there and look. I've already talked about going up there and looking at the area. There probably isn't a lot we can tell, but we, can get an idea of just the general surroundings.
The homeowner says he mowed the lawn recently and did not notice any kind of hole there before the fire.
What ignited it and what fueled it, we still don't know, and it may remain forever a mystery.
In Midway, I'm Caitlin Sinnett.
Yeah, did you notice they filmed a cell phone for the news? One person familiar with the property said that the hole wasn't new and had been there for years, so they are contradicting each other. But I think I leave it here. Maybe induced currents were the source or the reason for the fire. But geological people, they don't take electricity into account. Yeah, I don't know what's happening or what happens to this. Phosphorus-coated rocks. Anyway, interesting. Maybe it was something like this. Beautiful. Geology is very interesting. Thank you. Bye.